Now I am continuing from question number 4. In question number 4, it is asked that what are the primary and secondary signals in sensor or transducer classification? Give examples. So here we have to discuss about the definition of primary and secondary transducer with suitable examples. So at first I will discuss about primary transducer. So what is primary transducer? Primary transducers are those which can convert physical quantity into mechanical displacement. The force detected by the column in first, hence it is called primary transducer, and it is a mechanical device. So the transducer which converts physical quantity into mechanical displacement is called primary transducer. Example: board on tube, diaphragm, bellows, etc. Next part, that is secondary transducer. The transducer which can convert mechanical displacement into electrical output is known as secondary transducer. Output of the primary transducer is converted into useful signal by the secondary transducer, and it is basically an electrical device. Example of secondary transducer is LVDT, linear variable differential transformer. Next question, question number 5. In question number 5, it is asked that what are the different materials used in the resistance non-wire wound potentiometer? What are the relations between linearity and sensitivity of a potentiometer? So this question contains two parts. At first we have to discuss about different materials which is used in resistance non-wire wound potentiometer. We know that potentiometers are available in various technologies such as carbon film, conductive plastic, ceramic, wire wound, etc. The rating or resistive value of a potentiometer or variable resistor relates to the resistive value of the entire stationary resistance tracked from one fixed terminal to the other. Potentiometers with a linear output have a linear relationship between the mechanical travel and the output voltage. Linear potentiometers produce a varying resistance output determined by the displacement or position of a slider or wiper. The linearity of potentiometers involves variable resistance with 3 leads. The gauge factor is defined as the unit change in resistance per unit change in length. It is denoted by S or K. It is also called sensitivity of the strain gauge. Next question, question number 6. Question number 6 is derive the expression of gauge factor of a strain gauge. Okay, it is very much important question, derivation of gauge factor of a strain gauge. So I have already told about the definition of gauge factor. So gauge factor is defined as the unit change in resistance per unit change in length, and it is also called sensitivity of strain gauge. Now gauge factor S is equals to del R by R divided by del L by L. This is the basic expression, where S is the gauge factor or sensitivity, R is the gauge wire resistance, del R is the change in wire resistance, L is the length of the gauge wire, and del L is the change in length in stressed condition. Now consider that the resistance wire is under tensile stress and it is deformed by I, as sigma is equals to stress is equals to del L by L, So del L by L is the per unit change in length. Del A by A is per unit change in area, A for area. Del rho by rho is per unit change in resistivity, that is specific resistance. And we already know that resistance R is equals to rho L by A. Changes to R plus delta R because of change in length and cross-sectional area. Now dr by d sigma is equals to d R means rho L by A, rho L by A, d rho L by A divided by d rho, that is rho A into sigma L by sigma rho is equals to rho L into sigma A divided by A square into sigma rho L into sigma A by sigma delta into R A square, that is 1 by R A into rho delta rho by delta sigma. Now R is equals to rho L by A on the right hand side, so 1 by R dr by d sigma is equals to 1 by L into del L by del sigma minus 1 by A into del A by del sigma plus 1 by rho into del rho by del sigma. Considering del sigma from both sides, dr by R is equals to dl by L minus dA by A plus del rho by rho, that is del R by R is equals to del L by L minus del A by A minus del rho by rho. So this is the final expression. Thank you. In the last part, I will discuss about the broad questions. So group A and group B questions are all discussed. Now group C, I will discuss group C question answers on the next part.